Section 4.1 is talking about inverse functions. So the first thing I have here is something called a one-to-one function. It says a function is one-to-one if for elements a and b in the domain, if a and b are different, then f of a and f of b are going to be different. That is, different values of the domain correspond to different values of the range. There's something called the horizontal line test, and it says a function is one-to-one if every horizontal line intersects the graph of the function at most one time. Okay, so what they mean by that is if I draw a horizontal line, every time I draw a horizontal line, remember horizontal lines go left and right, I'm only going to hit the graph one time. As long as I hit the graph one time, then this function is what we call one-to-one, right? So if I do the same thing here and I draw a horizontal line and I hit it more than once, then this function is not one-to-one. Oops. Sometimes people say, sir, what happens if you draw this one right here? And they say, well, then I'll just draw that one. As long as I can find one vertical line that intersects it more than one time, it's not one-to-one. So again, drawing a horizontal line, I'm only going to hit that function once. This one here is one-to-one, and this one here is not. Okay, not one-to-one. All right. So all that means is if you think about, say, this function here, let me erase some of this mess here. If you think about this function here, suppose I go to this y value. This y value actually has two different x values that sent us there. That's what we mean by it's not one-to-one, okay? So when we have those y values that are the same, but the x values are different, then the function is not one-to-one, okay? All right, so we have something called an inverse function. And so first off, it says, let the function f be a one-to-one function. Then g is the inverse function if f composed of g of x is equal to x for every x in the domain of g, and g composed with f of x is equal to x for every x in the domain of f. Okay, so let's see if we can figure out what's going on here. It says, let f and g be functions defined respectively by, and it gives us the two functions, f of x equals x to the third minus 1, and g of x is equal to the cubic root of x plus 1. The first thing we're trying to find is f of 2. So remember what we're going to do. We're going to come back over here, and everywhere we have an x, we're going to put the number 2. So 2 to the third, minus 1. So 2 to the third means 2 times 2 times 2. That's 8 minus 1. That gives me 7. Okay. Now, it says, let's find g of 7. So I'm going to come back to this function here, and everywhere we have an x, we're going to put the number 7. So now we're looking for the cubic root of 7. Okay, let's see what that means. The cubic root, of 7 plus 1 is 8. Okay, so we've talked about square roots before, and if you remember when we did square roots, like I'm going to make this up, say the square root of 49, we said it was 7 because 7 times 7 gave me 49. We had a pair of them, right? Okay, well now we're looking at the cubic root. So instead of looking for pairs, we're going to be looking for triplets. We're going to be looking for sets of 3. If I take the number 8, I can break it down into 2 times 4, and if I take 4, I can break that down into 2 times 2. So how many 2's do we have? We have 3 of them. So g of 7 is equal to 2. Okay? So what I want you to notice here, the first one we found f of 2, and we came up with 7. So the x value that I got here gave me this y value of 7. And then what I want you to notice is we took that y value and we plugged it in for x in the other function, and we came up with 2, which was the x value we had the original time. So the question is asking me, is g the inverse of f? Are they doing sort of the opposite things? Well, one way we can figure that out is we can find the composition of those two functions. Okay? So we talked a little bit about composition before, back in chapter 2, I want to say it was. So remember, this is my inside function, right? So what is our inside function here? What is the value of g? Well, g is the cubic root of x plus 1, okay? So notice what that means. I'm going to take this value right here, and I'm going to plug it in right there. Okay. So f of the cubic root of x plus 1 is going to be equal to the cubic root of x plus 1 to the third minus 1. Well, this cube and that cube root are going to cancel each other out. That's going to leave me with x plus 1 minus 1, which leaves me with x. And so they appear to be inverse functions of each other. Okay. If I end up with x, which is what we had right there. Okay. So now it says, find the inverse of each function that is 1 to 1. Okay, so we can figure out if a function is 1 to 1. If you remember back in chapter, oh man, it was probably chapter 1 or 2, when we said, how do we know we have a function? We would say, well, the x numbers don't repeat. Okay. The way we figure out whether a function is 1 to 1 is now the y values won't repeat. So if I look at my y values, they don't repeat. Okay, so the way we're going to find the inverse just means that we're going to switch them. Instead of 3, 1, now we're going to have 1, 3. Okay, instead of 0, 2, now we're going to have 2, 0. Instead of 2, 3, now we're going to have 3, 2. Instead of 4, 0, now we're going to have 0, 4. And that would be my inverse function. Okay. So let's take a look at f. The first thing we want to figure out is the function 1 to 1? Do the y values repeat? So far, we're okay. Nope, they repeat. Those y values repeat, so there is no f inverse. Okay. This little power with a -1, the way I read that, guys, is f inverse. Okay. And so again, the way I would read this one here would be g inverse. Okay. So there's no inverse for this function because this function is not 1 to 1. In order for me to have an inverse, I have to have a 1 to 1 function. You can also see here that these y values also repeat. Okay. All right. So it says finding the equation of the inverse of y equals f of x. It says for a 1 to 1 function f defined by an equation y equals f of x, find the defining equation of the inverse as follows. If necessary, replace f of x with y first. Okay, so the first thing we're going to do, instead of writing an f of x, we're going to write a y. And then we're going to switch the x and the y. We're going to solve for y. And then the last thing we're going to do is, instead of writing y, we're going to write f inverse of x. Okay, so the first thing to do to find the inverse of this function, I'm going to write it, but instead of f of x, I'm going to write y. So y equals 2x plus 5. Okay, then we can start with our steps. We're going to switch the x and the y. What I mean by that is I'm going to write x equals 2y plus 5. And now we're going to solve for y. So let's bring this 5 over. It's going to become a minus 5, right? Because we're crossing the equal sign. And then let's divide everything by 2. Get rid of those. And we end up with y equals x minus 5 over 2. And then the last thing we're going to do is, instead of writing a y, we're going to use this little symbol. This means f inverse of x is equal to x minus 5 over 2. Okay? And we found our inverse function. So I want you to think about what an inverse function means, okay? If I were to take, like, say, f of x, right, my original function, which is 2x plus 5, and you were going to plug in, oh, I don't know, you're going to plug in a particular number. The first step we're going to do, we're going to multiply that number by 2, right? The second step we're going to do, we're going to add 5 to it, okay? The inverse is going to do the opposite steps in the opposite order. What I mean by that is, let me move this over. If I ask you to plug in a number here, the first step we're going to do, if you plug in a number here, is you're going to subtract 5. The second thing you're going to do, you're going to divide by 2, okay? So you're doing the opposite steps in the opposite order, okay? Think about it. Another way to think about this is, I know most of us are probably staying home because we're in the middle of a global pandemic, but if we were not in a pandemic and you were getting dressed, okay, first thing you're going to put on your chones, right? Pants, shirts, socks, and shoes, right? And then at the end of the day, when you would come home, what's the first thing that comes off? The socks and the shoes, right? That's kind of the idea here, all right? Yes, I said chones. All right, so let's come back over here. Let's see if we can do the same thing for this particular problem we got here. Okay, number one, instead of me writing f of x, I'm going to write y. Y equals 3x over x plus 5. Step number two, we're going to switch the x and the y, okay? So I'm going to write x is equal to 3y over y plus 5, okay? All right, now we're going to solve for y. So the first thing I'm going to do, guys, I'm going to think of this as a fraction over 1, and we're going to cross multiply. So I know 1 times 3y is still 3y. X times this is going to give me xy plus 5x, okay? I want to solve for y, so I'm going to move this guy over here because I want to get all my y's together. Okay. If you notice from here, I can factor out the letter y, and I'm left with 3 minus x is equal to 5x. To solve for y, I can divide by 3 minus x, and so we get y equals 5x over 3 minus x. And then the last thing I'm going to do, kind of running out of room, so I'm going to do it right here, is instead of me writing y, we're going to write f inverse of x is equal to 5x over 3 minus x. And here is my inverse function. Okay. So look, we got another one the same way. We're going to go about doing this problem exactly the same. First step, y equals 7x minus 3. Second step, x equals 7y minus 3. Now let's go ahead and solve for y. So let's bring this 3 over. X plus 3 equals 7y. Last step, let's divide everything by 7. And I get y equals x plus 3 over 7. And then my last step is f inverse of x is equal to x plus 3 all over 7. And here's my inverse function. Okay. All right. I'm going to keep scrolling down here. And it says, use a table for f of x to find a table for f inverse of x. Find or identify the domains and ranges of f and f inverse. Okay, so you know what? Since we're here, the domain of f, is going to be the set of the numbers 0, 3, and 6. And the range of f, will be the numbers 0, 9, and 36. Okay, so those are my x values and those are my y values, right? Now, if I'm going to find the inverse, remember we said the inverse is, we're going to switch the x and the y. So this is going to be x, and now this is going to be f inverse of x. And all I'm going to do is switch those values, 0, 9, 36, 0, 3, and 6. So the domain of f inverse is going to be 0, 9, 36, and the range of f inverse is going to be 0, 3, and 6. Okay. All right. Let me do this exactly the same thing here. It's the same type of problem. So let's find the domain of f. The domain, remember, is the set of the x values, 1, 2, and 3. The range are the y values, 4, 6, and 8. Okay. And now we're going to make a table for our f inverse. Okay, so x and f inverse of x. And I'm just going to switch the x and the y values. So this is going to be 4, 6, and 8. This will be 1, 2, and 3. So the domain of F inverse is going to be 4, 6, 8. And the range of F inverse is going to be 1, 2, and 3. Okay. All right. So now it says, use f of x to complete a table for f inverse of x. Okay, so we're going to see if we can fill out this table. So think about it this way. If I wanted to make a table for f of x, okay, remember, the range values are going to be, the range values for f of x here are going to be the same as the x values for the inverse. Okay, so what I'm trying to figure out is if here's my function f of x is equal to x plus 3. I want to figure out what number that I have to plug in for x so that this number here was -3, this number here was 0, this number here was 3, this number here was 6, right? So I might say, well, look, if x plus 3 is equal to, say, -3, when I subtract 3 on both sides, that gives me x equals -6. So I know I had to plug in -6 to get -3. And then I might do the same thing and say, well, what value did I have to plug in x plus 3 to end up with 0? So if I subtract 3 on both sides, I would get x equals -3. And if I did that again and said x plus 3 is equal to, in this case, 3, and I subtracted 3 on both sides, and we'd end up with x equals 0. And then if we did that one last time, x plus 3 was equal to 6, and we subtracted 3 on both sides, we'd end up with x equals 3. And now, if I know what this table looks like, right, because we just figured out those values, then I know what this table is going to look like. So look, the 3, 0, 3, and 6 are my domain. So the -6, -3, 0, and 3 will be my range. Okay. All right. So the last problem here out of 4.1 says, use the table to evaluate G inverse of -2. G inverse of -2. What does this mean? This means I'm looking for the x value when the y value, y value of G happens to be 2. So here's the y, here's G, right? This is my function G. Here's the y value being 2. What was the x value that sent me there? 3. Okay. So look, I can do another one like that. Let's do G inverse of 0. Okay. What does this mean we're looking for? We're looking for the x value of G when the y value of G is equal to 0. So here's the y value of G equals 0. What value sent me there? 5. Okay. Let's do one more. Let's find G inverse of 5. G inverse of 5 says go to the G value. Look at when you have 5. What was the x value that sent you there? 4. And that right there, my friends, is 4.1.